In this video, let's explore how to take input from users in C++ programs. C++ provides powerful tools for reading input from users through what's called the standard input stream. We'll cover using CIN for basic input, reading different types of data like numbers and text, handling common input errors, and some useful input formatting techniques. By the end of this video, you'll have a solid understanding of how to get input from users and handle it effectively in your C++ programs. Let's dive in. Let's start with the basics of using CIN in C++. The CIN object is part of the I/O stream library and represents the standard input stream, which is usually the keyboard. To read input, we use the extraction operator, which looks like two greater than symbols. CIN automatically converts the input we get to match the data type of the variable we're storing it in. Also, it skips any whitespace like spaces or tabs by default. Remember that CIN is part of the SE namespace, so we typically write std::cin. The typical way to use CIN involves 3 steps. First, we display a message to the user called a prompt using cout, asking them to enter some information. Then we read the user's input using CIN and store it in a variable. Finally, we process or display the input we've received. Let's look at an example. Here's how we can read different data types such as integer, double, and string. The code starts with include iostream and include string library. Then in the main function, we declare an integer variable age, a double variable height, and a string variable name. After that, the program prompts the user to enter their name using std::cout. Then it reads the input using std::cin and stores it in the name variable. Similarly, the program prompts the user to enter their age and reads the input into the age variable. CIN automatically converts the input to match the variable's data type. C++ also lets us read multiple values in a single line of code, which can be very convenient. We can do this by chaining the extraction operator with CIN. When we chain CIN operations, the values are read in sequence from left to right. Whitespace, like spaces or tabs, is used to separate the input values. The input stops when all the variables have been filled with the user's input. For example, consider a program that needs 3 integer inputs. The code starts with including the iostream library. Then in the main function, declare 3 integer variables, x, y, and z. The program prompts the user to enter 3 integers, then reads them in one go using CIN and the extraction operator, storing them in the x, y, and z variables respectively. Finally, the program calculates the sum of these numbers and displays the result. For example, if the input is 10, 20, 30, the output will be sum is 60. Reading string, that is text, with CIN has some limitations. The basic CIN command stops reading as soon as it encounters whitespace, such as a space. This means it cannot read full sentences with spaces. So we need special functions to read complete lines of text. The solution to this is to use the getline function, which can read an entire line of text, including spaces. To use getline, we need to include the string header in our program. When mixing CIN with getline, it's sometimes necessary to clear the input buffer to avoid unexpected behavior. Let's look at an example of how to read strings using getline. The code starts with including the iostream and string library. In the main function, we declare 2 string variables, name and full sentence. The program prompts the user to enter their full name. Then we read the full line of input using the getline function, which takes 2 arguments, CIN, which specifies the input stream to read from, and full sentence, which is the string variable to store the input. Getline reads until a new line character is encountered, allowing us to capture the entire input including spaces. Input validation is very important in programming. It involves checking whether the input provided by the user is valid before processing it. Validating input helps prevent program crashes, ensures the integrity of the data, improves the user experience, and protects against malicious input that could harm the system. There are several common techniques for validating input. One is to check whether the input type matches the expected type, for example, ensuring that the user enters a number when the program expects a number. Another is to verify that the input is within a valid range. For instance, if the program asks for an age, it should check that the age is within a reasonable range. Additionally, we can use error flags to detect input failures and clear the input buffer after failed attempts to prevent further errors. Let's see how to implement basic input validation in C++. The code starts with including iostream and limits library. In the main function, an integer variable age is declared. The program prompts the user to enter their age, then reads the input into the age variable. After reading the input, it checks if the input failed, or if the age is less than 0 or greater than 120. If any of these conditions are true, it means the input is invalid. In that case, the program clears the error flags, ignores the invalid input, and displays an error message. Clearing the error flag means using cin.clear function, and ignoring the invalid input means using cin.ignore function. By validating the input, we ensure that the program handles unexpected or incorrect data gracefully. Even with input validation, errors can still occur when using CIN. It's essential to handle these errors gracefully to prevent our program from crashing. Common input errors include type mismatches, such as entering a string when an integer is expected, buffer overflows, unexpected end of file, and format errors. C++ provides error state flags that indicate the status of input operations. The fail function indicates that the input operation has failed, the bad function indicates an unrecoverable stream error, the EOF function indicates that the end of file has been reached, and the good function indicates that no errors have occurred. Let's look at how to handle input errors in C++. The code starts with including the iostream library. In the main function, an integer variable value is declared. The program prompts the user to enter a number, then reads the input into the value variable. After reading the input, it checks if the input failed using cin.fail. If it did, the program clears the error flags using cin.clear, discards the invalid input using cin.ignore. Then it displays an error message. By handling input errors, we make our programs more robust and user-friendly. C++ offers several advanced input techniques that allow us to have more control over how input is processed. Input manipulators are special functions that modify how input is interpreted. Some common manipulators include std::ws, which skips whitespace, std::hex, which reads input in hexadecimal format, std::dec, which reads in decimal format, and std::bool alpha, which reads Boolean values as true or false. In addition to manipulators, C++ provides stream state control functions that allow us to further manage the input stream. These include cin.ignore, which skips characters, cin.peek, which looks at the next character without extracting it, and get, which gets a single character from the input stream. Let's see how to use input manipulators in C++. The code starts with including iostream and iomanip library. In the main function, an integer variable hex value and a Boolean variable answer are declared. The program prompts the user to enter a hex number, then reads the input in hexadecimal format using std::hex. Then it stores it in the hex value variable. After that, the program prompts the user to enter true or false and reads the input as a Boolean value using std::bool alpha, storing it in the answer variable. To use these manipulators, we must include the iomanip header. Let's wrap up with some best practices for working with input in C++. It's crucial to always validate user input to prevent errors and ensure data integrity. After encountering errors, always clear the input buffer to avoid unexpected behavior in future input operations. Use the appropriate data types for the input you're expecting, and provide clear and descriptive input prompts to guide the user. Make sure to handle all possible error cases to make your program more robust. For string input with spaces, use getline instead of basic CIN. Also, check the stream state after input operations to detect any failures. Some common pitfalls to avoid include mixing CIN and getline without clearing the input buffer, not checking for input failures, potentially causing buffer overflows with character arrays, and assuming that the user will always enter the correct data type. Here are some key takeaways. C++ provides powerful input mechanisms through the iostream library. Basic input can be achieved with CIN and the extraction operator. String input with spaces requires the use of getline. Input validation can be performed using stream state flags, and advanced formatting can be achieved with manipulators. For further learning, consider exploring the C++ standard library reference, file input-output in C++, stream formatting, and custom input operators. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.